3D printing is an art form, a functional art form, with stepper motors that can move the hot end which heats the filament at just the right temperature. 3D printing is an art form of precision, down to fractions of a millimeter. 3D printing sounds easy to mess up, but the impressive engineering over the years have allowed anyone to wield the power of that breed of machine. So whoever thought about adding one more dimension to a normal 2D printer is an absolute genius, because as it turns out, you can actually make so much with that. Want to make a model airplane? You can print it. What about a working organ? You can print that as well, if you are an MIT engineer. The best part is that you can make many functional prints with basic affordable printers. Maybe not a heart though. But just how can 3D printing applications be so large? The wide application is thanks to the different materials that 3D printers can use. Hard materials, heat-resistant materials, flexible materials, things of that nature are what make 3D printing so adaptable. But see for yourself. Okay, so we have two materials. We have white PLA, which is generally a general purpose material used for most things, like model airplanes or just prototyping materials. And we have black polycarbonate, which is essentially a much stronger material. It isn't brittle or as brittle as PLA, so it wouldn't snap. It would give a little bit and then break. And in general, it's really good for impact resistance. It's just stronger and more heat resistant as well. Okay, here we go. We got white PLA right here on the chopping block. I have no idea what will actually happen, so if it breaks, it breaks. Here we go. As you can see, white PLA is actually quite strong. 1 second. Yeah, that ain't gonna work. Ooh, there we go. Okay, congratulations. We have finally broken the PLA. Let's try and break this. Put some weight. Maybe some more brawn. I gotta work out more. Okay, there we go. So I was swinging it pretty high right there. But even then, when this broke, it gave out instantly. It's very floppy right now. But when this broke, it's still trying to give. As you can see, it's flexible before it breaks. This one, it kind of just bends very easily. This is obviously not an empirical test, because I literally just whacked it from the side of the table, and yeah. 3D printing is great, but is it for everyone? When I started about 8 months ago, I got my Ender 3 Pro and assembled it out of the box, and it actually worked for the very first time. I was very excited because it was actually much easier to start than I had initially thought. And then I started to see issues down the line. My printer started to clog, and at that moment I realized that no matter what printer you have, 2D or 3D printer, you will always get jams. The difference is that unlike 2D printers, 3D printers aren't designed to actually jam. It jammed because of my own very embarrassing mistake. And because of the open source design of 3D printers, I was able to actually fix my own problem. Open source essentially allows for interchangeability and upgradability of your printer so that you can fix your own printers or make it even better than you had ever hoped for. I fixed my issue after some tinkering, Googling, and just asking a lot of questions. My printer actually worked much better than I had anticipated. It printed much faster and at a much higher quality. So the question is 3D printing for everyone? Well, for someone who knew little about 3D printers at the time, it was easy to start, as most of the 3D printer was actually pre-built, so I only had to put in a couple of pieces, and I was pretty much good to go. However, it also depends on what kind of printer you get. But what if you don't want to get a 3D printer, but still want to see what one can do? Well, introducing PCBWay, the sponsor of this video. Metal 3D prints? They can do that. You can also get resin printing, SLA printing, FDM printing, CNC milling, and more, all within the palm of your hands within a few clicks. PCBWay, of course, makes PCBs as well, so if you just so happen to need a custom designed PCB made, then you can send it in and have it at your doorstep within a couple of days. Alright, back to 3D printing. This is Bill. He went online and bought a 3D printer worth more than $1,000. It does so many things like auto bed leveling and stops automatically when filament runs out. The thing is, his last name is Gates. Of course, he can afford it for his first printer, but for most of us, me included, we only want to shell out a couple $100, especially for our first printers. Here is a simple rule, however. If you decide to spend less money on a 3D printer, you would most likely spend a little bit more time tinkering with that printer. The opposite is true if you spend a little bit more money. Makes sense, right? My first recommendation is the cheapest of three, coming in at $220 to $230. The Ender 3 Pro is a pretty basic printer, but for me at least, worked right after I put the pre-assembled parts together. It extrudes filament and prints an object, so it gets the job done. It really does have upgradability because of the open source design, which allows for you to really make your 3D printer, your Ender 3 Pro, your own if you wanted to buy it. My second recommendation is a little bit more expensive, coming in at $270. It has more features than the Ender 3 Pro. It has auto bed leveling, a PEI coated bed for great adhesion when printing, 2 Z-axis lead screws so you can have better stability when printing instead of just one Z-axis lead screw, a dual gear direct drive extruder for better print quality, a nice touch screen, and a partridge in a pear tree. For only about $50 more than an Ender 3 Pro, those upgrades are insanely good. I mainly got the Ender 3 Pro so that I can tinker with it, mainly because, my channel name. Finally, we have Bamboo Labs P1P printer. It comes in around $600 to $700 depending on the sale, but it has the same features as the Neptune 3 Pro and so much more. It has a filament runout sensor, semi-automatic belt tensioning, which is something I manually have to do on my Ender 3 Pro, a much wider compatibility with different print materials, much faster print speeds, and software vibration compensation, allowing for the very fast print speeds. Maybe we can even print in an earthquake. This is the perfect printer, or a very good printer, for beginners to get started in 3D printing and who want to just get started right away and very reliably. It has pretty good upgradability, but you probably would not need to upgrade it because of its insane upgrades at only $600 to $700. Links to all of these printers can be found below. If this video is helpful to you so far and you are enjoying it, please consider leaving a like down below and subscribing. I appreciate it. Alright, so let's imagine you got your printer, or maybe you already have one. How do you start printing? Well, let's simply go through the process of transforming a virtual object into the real deal. Number one, the file itself. Of course, you need to choose your object in the first place and transform it into an STL. You can go onto Thingiverse online or any other 3D printing object sites online and download it from there, and then transform it into an STL file. You can also design your own object and also export it as an STL, and then transfer it into a slicer. And that segues into our next point, which is number two, the slicer. We need to turn that STL file into instructions that the 3D printer can read in order for it to print an object. I say we, but we actually don't need to do much. The slicer software actually does most of the heavy lifting, and all we have to do is actually just press a couple buttons, a couple settings, and we should be good to go. Typically, you would need to select your printer type, then filament you'd be using, so that the slicer can write the correct instructions for the right printer. The nice thing, at least for what Kira does, is that once you put in your filament type, it has pre-made quality settings that you can choose from, ranging from low to high quality in general terms. For beginners, you do not need to change any of those pre-made settings. Number three, choose whatever quality you want, and how much infill, which is essentially how much material you want inside the object itself. Higher percent means denser and in general a stronger object. Turn on supports. Sometimes you don't need supports, but for beginners, it is good to have them on. Press slice and get your file to your printer. How you get your file to your printer would depend on the printer itself. Some printers have micro SD cards, others require USB connection, while others have Wi-Fi. And some might just have all of them. Number five, leveling the bed. So if you have a bed that levels itself, so an auto bed leveler, then great. You're all set to go, you just have to press a button and you're basically good to go. For manual bed leveling, I slide a sheet of paper back and forth between the nozzle and the bed. Then I turn the knob until I feel slight roughness from the paper. I do this for every corner of the bed and a few times to be sure. This is to have the nozzle about a paper's width away from the bed, which should be good. Number six, print. And that is basically the entire process. A bit longer than getting a normal PDF to print on a normal 2D printer, but it's not too bad. Alright, so here are some general tips that I would have wanted to know before I got into 3D printing. Number one is to take your time. So 3D printing is a very precise art, as I've said before, and you gotta take your time to build and assemble your printer correctly so that your prints can come out right. Number two, Google. So 3D printing, fortunately, has a very big community because of how many people get into 3D printing. which means that there's a lot of answers and also a lot of questions that get answered. So if you have a question or if you have a problem with your 3D printer, chances are you can Google it and you will get a solution. Number 3 is general maintenance. So when you hear maintenance, you might steer away a little bit, but it's not like every week or anything. Typically it's every month or every few months. So typically what you would have to do for maintenance would be maybe clean off the dust inside of your hot end. The other thing you might have to worry about is a nozzle. So typically 3D printers come with brass nozzles, which can wear out a little bit every single time you print. Of course, if you don't print that much, then you wouldn't have to replace the nozzle or do a lot of maintenance in general. But if you do print a lot, then you will have to change the nozzle more because the nozzle would wear out more the more times you print. Who said you couldn't 3D print a 3D printer? I hope this video has helped you and that you enjoyed this video. Printing objects that you download from the internet is great, but what if you can design your own objects? Maybe an RC car, maybe a drone, or maybe just your own model airplane. Turns out you can with CAD, which you can learn the basics of in this video. I'll see you in the next one.